Okay, welcome to the lesson on permutations. So we're going to start this lesson with a simple example. So if three different students, student A, B, and C, I'm not going to give them names, run a race, in how many different orders could they finish that race? So, if this were class, I'd have you, try to come up with all the different orders. Let's write down all the orders. Well, student A could win, then B second, and C third. Student A could win, and then C could be second, and B could be third. Student B could win, student A could be second, C could be third, or B wins, and then C then A, or C wins, A, B, and then C, B, A. And that's all the possibilities. So there are six ways, 6 orders. Now, hopefully I got them all. I know the answer, I did get them all. If there was more than 3 students, you could see this could be pretty difficult to list them all. So is there another way to do this? And the answer is yes. This is really a fundamental counting principle question. So fundamental counting principle. So if you remember, for fundamental counting principle we need different actions. So what are the actions? Well, the actions here are the first person finishes, the second person finishes, the third person finishes. So action 1, how many ways can someone finish first? Or how many people could finish first? If the race is being run, there's 3 people that could cross the line first. So 3 ways that action 1 could happen. Action 2, remember we're running the race, so someone has already crossed the finish line. So now how many ways could someone cross second? And a lot of people will say 3 ways. The answer is not 3, the answer is 2 ways. Why is it only 2? Someone's already finished first. So there's only 2 people left. Okay, so that first person that crossed the finish line, I don't know which one it was, can't finish second now. In action 3, well, by the same logic, now there's only 1 person that could finish third. So there are 3 times 2 times 2 times 1 equals 6 orders. Okay, so really we're just using a fundamental counting principle. And you have to remember that when you're placing the people, or when they're running the race, it's going to go down each time because someone, the previous person has already finished. And this might remind you of something that we just did with factorials. So this is an example of what we'll call a permutation. So I'm going to write the definition down and then discuss it. Okay, so here's our definition. A permutation of n objects, so that's how many objects you had. In this previous example there was 3 people, so n was 3, is an arrangement of all the objects. So in this example up here we had 6 permutations, so all of these are your that's permutation 1, 2, 3. So all these different orders are your permutations. And usually what we care about is how many permutations there are. So the number of permutations of n objects is denoted p bracket n comma n and is equal to n factorial. So we saw up here in this example when we had 3 objects, the number of permutations was just equal to 3 times 2 times 1, which was 6. So we had 6 permutations of the 3 objects, the 3 people running the race. So let's do another example. Okay, another example. A rock band has 10 songs it knows how to play, and A, how many orders could it play these 10 songs? So they're playing a concert, and how many different sort of arrangements of these 10 songs could it play? So this is asking how many permutations of these 10 songs are there. So in this case, n is equal to 10. So p 10 10 is equal, so this is, remember our definition, p permutations, n is 10, 10, and this should be equal to 10 factorial, which is equal to, it's equal to that. So what's that? 3,628,800. So just with 10 songs, there's that many different orders they could play in it. Okay, and then you could, if you want to reason it out, there's 10 actions, right? They have to play a song first, so how many songs could they play first? 1 of 10. How many songs could they play second? Now there's only 9. Then they could play 1 of 8 songs, 7, etc. So that's why it's 10 factorial. So B, let's change this up. Let's say they don't have time to play all 10 songs. Let's say how many orders could they play? Three of these 10 songs. So they just can do a short little set. They're only allowed to play 3. They only have time for 3. Well, it's not a permutation of 10 objects now because we're only looking for 3 of them. So we're not going to be able to do this. But we could reason it out like this. So let's say action 1 is playing that first song. How many songs could they play first? 10. Action 2, how many songs could they play second? 9. Action 3, how many songs? 8, and then they're done. So therefore, there are 10 times 9 times 8, which is equal to 720 orders. So they're only playing 3 songs, but there's 720 ways that could happen because they know 3 songs. And this is still a permutation, but it's not a permutation of n objects. Well, sorry, it is a permutation of n objects, but we're only arranging 3 of them. So what we'll say in this case is a permutation of 10 objects taken 3 at a time. So there's 10 objects, but we're only taking 3 of them. So I'll write this permutation definition down too. Okay, so this is what we call a permutation of 10 objects, because there was 10 songs taken 3 at a time. So we are arranging 3 of the songs, or 3 of the 10 songs in a definite order. So the letters we're going to use, so 10, that's still how many objects we have, so we use an N for the total number of objects, and we use an R for how many objects we're arranging. So we use the notation, and it's basically the same notation, P, N, and now we're only arranging R of them, so instead of saying N again, we say R. So that's, remember that notation here, you might have said, why do I have to write N twice? It's because you had 10 objects and you're arranging all 10 of them. But now, if you're only arranging a smaller number, you write it there. And the way we do this, it's going to be n factorial over n minus r factorial. And you might be saying, where did this thing come from? How did I get that? Well, remember this example up here, where we had, we've already done this one, right? P of 10, and you're arranging 3. So we remember this was equal to 10 times 9 times 8. Well, how do you get that? What's a mathematical way of getting that? Remember when we did factorial notation, we said if you do 10 factorial over 7 factorial, that's equal to 10 times 9 times 8 times 7 times 6 all the way down over 7 times 6 times 5 times all the way down, and all that cancels with all that, and you're just left with 10 times 9 times 8, which is what we wanted over here. So this is really equal to 10 factorial over 7 factorial, and 7 is just equal to 10 minus 3. 10 minus 3 factorial, which is where we get this thing. So this is what you have to remember, that if you have n many objects and you're arranging r of them, then it's equal to n factorial over n minus r factorial. So, very straightforward example, find the number of permutations of the letters in the word diploma. So, how many objects do we have? N is equal to 1, 2, 3, 4, 5, 6, 7. So there's 7 objects and permutations of the letters, so that means all of them. So we are doing 7 and we're permuting all 7. We're arranging all 7. So that's just equal to 7 factorial, which is equal to, oh yeah, we did it already, 5,040. Okay, example B. Same example, but now the L remains in the middle position. So notice that the L is in the middle. So we have 7 positions that need to be filled in. 6. And the L has to be here. So I can't just go straight permutation. What I'll do is I'll think about fundamental counting principle. I'll think about placing these letters. Since I know the L has to go here, I'm going to place that first. How many ways could I well, never mind. How many letters could go in this first position? In the previous example, it would have been 7. But now, since the L has to be here, there's only 6. How many here? Well, now there's 5 left and 4 left. How many can go in here? Well, there's only 1. The L has to go there. 3, then 2, then 1. So really, this is equal to 6 factorial with a times 1 stuck in the middle there, but that doesn't matter. So 6 factorial is equal to 720. So there's 720 permutations where the L is in the middle. Just try listing all those. That'd be pretty difficult. So it's a good thing we know how to do this. And then another one where the O and I must be together. So we've got these letters D-I-P-L-O-M-A, but now the O and the I and the O must be beside each other. So what we're going to do is, remember there's 7 positions, but since the I and the O are together, we're going to treat them as one. So treat O and I as one unit. Now only 6 positions. So before there was 7 positions, but since the O and the I are one unit, we only have 6 positions. So that would be 6 factorial, and again 720. And you might notice that's not quite the answer, because this is where I was treating the O and the I as one unit, but O and I had to be in this order. But it could be OI or IO. So there's actually going to be twice as many as this 720. So it's really going to be 6 factorial times 2, which is equal to 1440. So we double this answer because for each OI there's now an IO.